In today's lesson, lesson 6, we did a gallery walk where each group worked by themselves to create a table for their given ratios and a graph for the given situation. And then they were asked to figure out if it was proportional or non-proportional by themselves and hang up their poster while we walked through and identified just by looking at the graph and the chart and the table rather, if the relationships were proportional or non-proportional. So the most important thing that we need to remember when identifying proportional and non-proportional relationships on tables and graphs is looking for a constant. So if I have a table, I'm going to put two tables. It doesn't matter what situation we have, but I'm going to call the left one X and the right one Y. They are proportional if there's a constant that we can multiply by X to give us Y. So for instance, if I start with 1, I can multiply it by 6 to give me 6. And if I multiply 2 by 6, I will get 12. And if I multiply 3 by 6, I will get 18. This is proportional because there's that constant 6 that we can multiply by. Over here, let's say I have this information. This is going to be a non-proportional example. Okay. In this example, I look at the first entry and I realize, oh, there's a constant, and I can multiply it by 6. But in the second one, the constant to get from 2 to 10 is 5. And then the third to get from 3 to 24 is 8. So since the constants, each of these, the constant proportionality, is not the same, it is a non-proportional relationship. And when we graph these, I'm just going to sketch a graph for you. When we graph these proportional relationships, will always be a line, a straight line, that starts at the origin, at point 0, 0. And the reason for that is if we have an input x and it's 0, no matter what the constant is, in this case it looks to be 7, you're still going to get 0 for the y, because anything times 0 is 0. If my constant was 13, then I would multiply 0 times 13 and it would be 0. No matter what number you multiply by 0, it should be 0. So if I have a non-proportional graph, it may not start at 0, 0. It might start at 0, 4. Okay? That is not proportional because there's nothing I can multiply by 0 to give me 4. So I might have a point here, point here. This is not a straight line. The points are all over. So if I were to try to draw a straight line, you can see it wouldn't touch the points. We can draw a line of best fit, but that's not what we're asking. We're asking, can we graph the table onto the graph and spot right away if it's proportional or non-proportional? So the two things you are looking for are a straight line and it starts at the origin.